Got a question on number 17 from section 9.10, so we'll take a look at that. First part of this is really a review. I'm not really sure where the question might be coming in, but the first part here is really a review of what we did in section 9.8 and just kind of a running theme that we've had of trying to do a lot of different things with right triangles. So they asked for the length of PT, and basically you need to find a right triangle that has 2 out of 3 sides. Remember that the altitude will go down to the middle of the base of a square pyramid. So if this whole side here is 20, this horizontal length here is going to be half that length. That's going to be 10. And so what we actually have here, and again, cannot stress it enough, make sure you're drawing separate pictures. These are complicated diagrams that turn into very simple problems when you isolate the thing that you're actually working with. Okay, so we're looking at triangle PFT here, okay? It's got a height of 35, it's got a base length of 10, and right now I'm trying to find the length of PT. I was hoping that might be a Pythagorean triple. I'm not seeing anything here. If I divide both of these by 5, I get a 2 and a 7, and I don't think that's going to give me anything. So let's do a little Pythagorean theorem here. 35 squared plus 10 squared is equal to x squared, and let's see. It's going to be the square root of 1325. The back of your book rounds it, but the question doesn't say to round, so you really should leave it as a radical. 25 goes into 1325 53 times, so I would write this as the square root of 25 times the square root of 53, which would be 5 radical 53 would be the best solution there. Okay, so 5 radical 53 on that side, kind of messy. I think it's about 36 point something if you look at the answer in the back, but again, my answer is a little better than what the back gave you. All right, BP. So BP, oh, is BP what I just found? Well, BP is what I just found, so sorry. No, BP is right here. Okay, so we just found PT. We could say it's radical 1325, or we could say it's about 5 radical 53, one of those answers. All right, BP, same kind of thing. You've got a right triangle here. We now know 2 out of 3 sides on that right triangle. And by the way, you've got a bunch of different ways to do this too. You could have used, you know that the base is a 20 by 20 rectangle. I'm sorry, 20 by 20 square. So you know that that's a 45, 45, 90 triangle. You know the entire diagonal is 20 radical 2. So half that diagonal is going to be 10 radical 2. So you could use a right triangle with a length of 35 and a 10 radical 2, and then use that to find the other length. A lot of these problems you're going to have more than one way to do it. I'm not going to do it that way because I already have PT, and why not use that? So we're looking at this sideways right triangle here, and they were nice enough to tell us that there's a right angle there. So anyway, we're looking at that sideways triangle now. So we have PTB, looking at this guy right here. We know that BT is going to have a length of 10 because it's half of a side. I would not use the 5 radical 53 because we're going to be using the Pythagorean theorem. I think it'll actually be a little cleaner if you use that PT length of radical 1325. It's another reason not to use the decimal answer in the back. If you're going to reuse the answer, you don't want to have a rounded answer because you're going to incorporate error into the problem. So anyway, BP is just the hypotenuse of that right triangle. So we're going to take 10 squared plus radical 1325 squared, and hopefully you can see now why I left it as a radical, and that's going to be equal to x squared. So that's 100 plus 1325 is equal to x squared. X squared is going to be equal to 1425, and that basically means that this is going to be the square root of 1425. I do think 25 will divide out of that. I don't think that's a perfect square, but let's check real quick. That is not a perfect square. 25 goes into 1425 57 times. So you can break that down into radical 25 times radical 57. So you could write that as 5 radical 57. Probably be the best way to write that. All right. Now, they ask us for a couple of angle measures here, and I think this is where the trig is going to come into play. And possibly some of the answers that we already had may also need to be used. So let's see what's going on there. They want the angle PTF. All right, PTF, that's this angle right here, okay? So going back to that triangle, which I really should have found at the time, I guess, you know, we knew that this side was 35, and we knew that that side was 10, and we're looking at PTF, we're looking at this angle right here. We don't really need to use that radical 1325. You know, if you made a mistake with that, if you don't trust my answer, use the values that we know for sure, the 35 and the 10. So remember, the big idea in this unit, and one of the things that I love about trig equations are the same every single time. It's either a sine, cosine, or tangent. You've got an angle measure, you've got two sides. Almost every time one of them's a variable, you just pop everything in, you solve for the thing you're missing. So based on mine, I have an opposite side and I have an adjacent side. Okay, opposite over adjacent is tangent. So we're going to have a tangent of the angle measure. We don't know what the angle measure is. I'm going to call that, I'll call that angle theta. Okay, so the tangent of angle theta is equal to the opposite over the adjacent. It's equal to 35 over 10. Okay, you can't type tangent of x or tangent of theta if you want to use the angle variable. You can't type that in your calculator. So remember, you're going to have to use the inverse tangent. Remember, inverse functions, which you'll learn more about in Algebra 2, switch the input and the output. So instead of putting in the angle and getting back the decimal, we're going to put in the decimal fraction, we're going to get back the angle that goes with it. Make sure your calculator is in degree mode before you do this. And we'll just flip-flop these two. We'll use the inverse tangent of that angle, sorry, of that fraction there, sometimes called the arc tangent, by the way, in some books. And the inverse tangent of 35 divided by 10 is about 74.05 degrees. I think 2 decimal places is probably fine. The question doesn't say what to round to, so we'll go with about 74.05 degrees for that one. And finally, we'll close this out with PBF, which is, I think, using that other triangle that I should have left up on the board, but hey, happens. All right, so we're looking for PBF. PBF is this angle right here on that triangle. So we've got a 35 there, and we had that length that I had right there. We said that PB had a length of 1425, so I guess we'll radical 1425. So we use the 35 there. This is triangle PFB, and I'm going to use the radical 1425 there. You could use 10 radical 2 there as well. If you did it that way, you'll still get the right answer. And same kind of thing. We're trying to find the angle at vertex B. Okay, we need to pick the trig rule here. We've got an opposite side in my version and the hypotenuse, and that's going to be a sine. So it's sine of whatever we want to call our angle. I'll call it theta. Sine of theta is equal to opposite, 35, over radical 1425. Once again, we don't have the angle. We're looking for the angle, so you're going to have to use the inverse sine function, or the arc sine. So take the inverse sine of 35 over radical 1425, and I will type that in. Don't forget the radical. Don't forget to hit the second button before you hit the sine. And that's going to be 35 over radical 1425. And that looks like it's going to be about a 67.998 degree angle. Actually, with an 8 there, that's going to round it up one. It actually rounds up to 68.00 degrees if you're going to 2 decimal places. Okay. Again, it doesn't specify, so I can't really complain a whole lot one way or the other, but we'll go with that. So a little bit more going on in that problem than I thought. Pretty tricky. Hope that helped.